cool. I will go ahead and make the announcement. I wanted Carlos to do it because he's self-promoting his Twitch channel. So he is streaming again on Twitch every weekday at noon. That's Mountain Time. And that's a free, easy way to support QAP. There's also additional ways to support QA at the Point. You can join our YouTube channel, subscribe to the YouTube channel. And then, of course, it's really easy to go to whatever social media outlet you use and like, retweet, requote, post, whatever else you can do. We're on Instagram, Twitter, Facebook, LinkedIn. And if there's something else that people are really interested in, then let us know, and we'll go ahead and add those as well. All right, and then expansion is coming, and this is July 28th, so just next week. If you haven't already signed up, hopefully you can still do so. And a lot of great speakers. Again, Carlos, I think you're self-promoting quite a bit here. Since you're not defending yourself, I get to talk about you. But here we go. Carlos is speaking at this event. And for those who are local to Utah, this is a great opportunity to meet up and get to hear from the QA community here in Utah. All right, and then manual button pushers. This is promoted by QA at the Point. They are meeting August 12th, as you can read here on the slide. 7 p.m. The topic will be accessibility tools, and the presenters are Russell Johnson and Amber Ostendorf. Thank you, manual button pushers, for pushing this along, doing a great job, and the topics have been really good, so thank you. So promoting that. And then we want to thank again Test AI, and for those who are curious when we will do the drawing will take place after Tariq's presentation, maybe during the Q&A, maybe after the Q&A. We kind of like the suspense. And so it'll be sometime in there, but now you know when you definitely need to be here. Of course, listening to Tariq's presentation is the highlight of the night. So you definitely want to be here for all of that as well. All right, so what's up? This is part of the exciting news, at least in my opinion it is. So we have a great lineup coming soon. We've got Julia Pottinger. She's going to, you can see the topics here. I'm not going to read through all the topics, but Joe Colantonio. And then I'm going to highlight Carlos again. Carlos, holy smokes, you're everywhere tonight. So in October, Carlos is going to speak, but the exciting part besides Carlos speaking is that we're actually going to meet in person. We do not have the location decided yet, but we're excited that we're finally going to meet in person again. So we invite everyone local, and hey, if you're not local and you want to fly in and join us for the meetup, we invite you as well. We are going to work on streaming it, so it will be available for everyone around the world, just like this event. But we're excited that we finally get to meet again in person.
Cool. All right, so hello everyone. I mean, this is great. Thanks for taking the time to join, number one. And then let me just say a special thank you to the organizers of QA at the Point. Like, I've always keep hearing about QA at the Point, really cool name for a meetup, number one. And I even work with Kevin now, but still for months went by and never got an invite. So when he finally pinged me and was like, hey, want to have you on the Point, I was like, this is great. So really happy to be here, really pleased to have a big turnout like this as well. So today I'm going to take you on what I'm going to call a tour de force of AI for software testing. And the idea for this talk really came from something Jason Urban, our CTO and my buddy, said one day. He was talking about a keynote that he gave at Eurostar, and he was like, you know, that was just like a quick tour de force of our coolest tech at test.ai. And I must say, honestly, like the sentence itself sounded a bit strange, right? Especially because the word quick makes you think of, especially in the context of Tour de whatever, makes you think of the Tour de France, right? Which is very different from a Tour de Force. It's probably a Tour de Force in itself, but you know, the Tour de France is really an annual cycling event that predominantly takes place in France, but also makes an occasional pass through other adjacent countries, right? And you know, this was the route in 2021. But a tour de force is a feat or display of strength, skill, and ingenuity, right? And so, I thought about it a bit on what Jason said and kind of how it resonated with me. And I said, well, it might be cool to give a talk that puts these two things together, and not just for test.ai, but really the entire space of AI for software testing. And so our agenda really is one that kind of combines a little tour of the AI for software testing space, right? And we got our little bot mascot riding around as part of the theme. But first, I'll really get into a background on what is AI for software testing, including different AI and ML approaches that are commonly used for test automation. And then we'll get into our tour, which, like the AIST kind of displays of feat, is looked at from different perspectives from over the years, right? So we're going to look at it by testing level, by quality attribute, and then by problem domain. And of course, we won't be able to cover every problem domain, but just a few that are pretty interesting. And then we'll wrap up and take questions and hang out. So, all right, so some quick background on terminology and stuff so that we're on the same page. So when it comes to artificial intelligence, that's this broad field of computer science where we're really trying to get software to learn and reason like humans should, right? Intelligently. And that's a very big and broad field, and it encompasses what is called machine learning, which is a subset of AI that really deals with the programming model. And so, traditional programming models give computers step-by-step instructions, right, in this imperative manner: do this and do that. But with ML programming, algorithms enable the machines to learn from data examples rather than these hard-coded instructions. And so this is a major paradigm shift where even instructions are becoming data. And then last but not least, deep learning is really a subset of machine learning that deals with large scale computational learning. And so when you hear this term, you should be thinking about training neural networks that have many, many layers and using relatively large data sets. And we'll get into neural networks a bit as we look at this. All right, so when it comes to machine learning itself, there are three roughly broad categories of machine learning. There's supervised learning, unsupervised learning, and reinforcement learning. So under supervised learning, humans are providing the machines with these labeled examples, right? So here's a type of a cat, or here's different types of dogs, and you're, sending those labels to the machine. And when the machine encounters an example that it hasn't seen before, like here's a new picture, it tries to take an educated guess to classify it based on the previous examples that it has seen. And so, in essence, what it boils down to is that you're really solving a classification problem after learning based on known patterns. With unsupervised learning, you're kind of letting the machine loose on labeled data, right? The machine then will partition that data based on certain features or characteristics. And this is a process typically called clustering, right? It's the most common form of unsupervised learning you'll run into. And whereas classification assigns a label, right, to your data, like some aspect of the domain, this is a flower, but clustering just takes place on that whole bucket. You don't need to know the label. And this type of learning is good for discovering new patterns in data. In other words, the machine teaches you something new that you didn't really recognize before about the data that you have. And last but not least, reinforcement learning is really about learning by trial and error, right? So you have an agent in an environment in some state, and it takes some actions to transition to a new state. And what you're using is some type of a reward system that helps the agent to learn the desired behavior to reach whatever goal you have, right? And so reinforcement learning in combination with deep learning is where you see a lot of the modern advances in AI being realized, right? So from things like playing Go to Atari games to self-driving cars, it's all a lot of reinforcement learning combined with deep learning or deep reinforcement learning. All right, so this idea of artificial intelligence for software testing, or AIST, and this is really this field that has emerged where we're looking at three areas in particular, right? Number one, the development of AI systems that help to test software, different methods for testing AI systems, and ultimately, we'll talk about this briefly at the end, this future where the machines might actually be testing themselves. However, the tour de force is specifically focused right now on AI-driven test automation, and we'll see maybe how over time this might expand into other areas, because I think it'll become necessary, and these three things, as you see, actually intersect. All right, so back in 2017, 2018, I gave a keynote called Rise of the Machines, Can Artificial Intelligence Terminate Manual Testing? Now, this was actually like my very first keynote, believe it or not. Folks always like tell me like this is the favorite keynote they ever seen from me. And I was like, that's great, because that was my first one. And I gave that at Star West and then PNSQC, and I would go on to give it all over the place. Like here I'm in Romania at Code Camp in front of 2,800 people, right? And the goal of the keynote was really to start to inspire the testing community to embrace the possibility that AI could really be a power up to traditional or conventional test automation techniques, right? In other words, like traditional automation are those smaller part pellets, I would say, and AI is this big power pellet, right? So the smaller pellets don't really give Pac-Man any kind of ability to do anything against the ghosts, in which case these are the testing challenges. Whereas the power pellet actually can help him to overcome or eat the ghost, so to speak. And so this talk is really just a follow-up check along the way to see since then, where are we, right? And we'll get into some different dimensions on our tour de force, right? As I mentioned, the different levels. But it's important to note that even though we'll look down these different dimensions, they're really very intertwined and interconnected. And so you'll probably be able to identify the interconnections as we go through. All right, so first let's look at how AIST is being applied at the UI level, API level, and the unit level, right? So we'll look at these so-called levels of testing. And much of the industry is actually focused right now on applying AI for software testing, on building the next generation of GUI level automation. And so there's companies and startups, including us, that are leveraging AI to do functional testing of web and mobile applications. And so, our platform, which we internally refer to as Carbon, is like our bread and butter and our prized possession that allows us to do this type of testing with AI. And what I really like about test.ai in particular is that we haven't just stopped with a single suite or even enterprise or mobile applications, right? We've gone into other areas and looked at the bigger picture. So we're leveraging AI for testing entire app domains or the entire app store, right? Our mission is to test the world's apps. And of course, when you get a mission statement, it should be bold, and there's nothing bolder than saying that we're basically going to test everything. And we're also applying it to testing modern video games and doing things like testing video quality and video streaming. And so for us, AI is really like our superpower, right? Especially at this level, the UI level, we like to think that we can use AI to test anything with a screen, right? And if there's a superpower, the next thing that you naturally might think about is that there may be something that lessens that superpower, right? Some form of kryptonite, so to speak. And for me personally, I believe that the kryptonite in this space is the complexity. AI is kind of like magical, but it's kind of the scary kind of magic, right? It's not the fun kind of family magic that you go watch. And so one of the goals that I usually have when I speak is to educate folks on how this technology works, the different strengths and weaknesses. And so hopefully we can start to build trust into the community for this software and bring value where it makes sense to apply it. And so you'll see that at each point in these stops on this tour de force, we'll look at how it works underneath the hood as well. All right, so I threw this in here as a reminder that it's not just the flashy stuff like games and streaming services that makes AI for software testing powerful, right? We've been working with my buddy Jeff Marr over at Dell, trying to figure out how we can tackle some of the not so flashy automation challenges that large customers might face. And so this is our product actually running and identifying elements on a system BIOS configuration screen. And so challenges like this, like I said, aren't the prettiest thing, but they have value to organizations that don't have an automated solution for this, right? I would never think that we could automate a BIOS screen, well, except for very rudimentary, trivial keyboard type stuff. but actually verifying the screen and other things, like that's pretty powerful. All right, so how does this work? How does this AI for UI testing actually do its thing, right? The first thing is that we leverage computer vision to recognize screens and elements just like humans do, right? That's why it's about anything with a screen. And along the way, the bots will build a model of the application to help deal with uncertainty and help, even with test generation, which is the next important step, right? You got to be able to generate test inputs and verify outcomes, all using machine learning. And then last but not least, obviously, the whole point here is that over time, the bots will improve, right? They learn, they get better. As you train them, the more labels you add or the more they can explore on their own, they get better at testing the app and giving you feedback. And using ML at this level really allows us to build more robust and resilient automation. And so the bots are not tied to the DOM. You don't have to use like CSS selectors, and which you got to update whenever the application structure really changes. But instead, they're trained on thousands of images and examples so that when you update the look or feel of your application or your game, it still works, right? And then the bots can use reinforcement learning, that trial and error, to relearn and rediscover newer updated paths through the application. And so that's really the value point of using AI at this level. And I couldn't really talk about this without mentioning this guy, Diony Santiago. He's a personal friend and also director of engineering at Test.ai. He does that during the day, and then at night he's this like superhero that does his master's and PhD. I don't know where he finds the time to do all this stuff, right? But in his master's thesis, his approach to generating UI level tests for form-based applications, and he does that using things like boundary value analysis, equivalence partitions, script injection, and he's incorporated all that into an open source prototype called Agent that you can find out there for educational purposes. But it gives you running code examples of how this stuff works. So you don't have to take my word for how it works. You can go and download that project and look at it. Just search for AI generation and exploration and tests on GitHub, and you'll find that. And without getting into too much of the nitty gritty of his master's thesis, what Diony does here is basically combine ML-based text generation techniques with this abstract testing language, right? And so this allows you to seed some preconditions in and then have the machine keep generating new tests, right? And a lot of this technology you'll see up there is used for what AI does to generate, text, right? News articles or books and stuff like that. So it's really just a translation of some of that work into the testing space. And so for me, this is definitely a tour de force. And I know Diony recently completed his proposal. I actually sit on his committee as well. And he's about to extend his work using hierarchical models. So if you guys don't already follow him or have him on LinkedIn or Twitter, please feel free to do so. I'm excited to see where he's going to go with this. All right, now at the API level, right? And this is also some very, very cool work that's coming out of Liberty Mutual from Gordon Merritt. So Gordon, I ran into Gordon because I saw him on LinkedIn talking about the patent, and then I looked up the patent, and it's really a project that he codenamed Sarisha. And kudos to him on the patent and just even having the boldness to kind of reach out into this space and do something different, because there's a real big gap right now in the space where a lot of folks are focused on AI for UI testing, and there's not as much attention on the API level, which we know is very, very important, especially when it comes to testability and that sort of stuff, right? And so how this works at the high level, again, is that he uses test patterns and the past history of API runs to really teach the machines how to generate test inputs, right? How to determine the correctness of outputs, which tests to prioritize and other things, right? And so what he does is he leverages an API specification language, probably something like Swagger, to help with the test generation and the learning process. And, as I mentioned, this is a big gap. And, even though this is an internal tool and it's nothing that's out there for everyone to see, I think just having the idea pushed out to the community is a big value add. So yeah, major respect to Gordon for that. Another approach on the automated API testing front, which you'll see out there, is this idea of recording service traffic, right, from manual testing, and then using that information to train some ML-based test generation system. And this approach stems from your popular record and playback that you're probably all very familiar with in the early days of functional automation tools. And so you'll see this pattern in other places like performance testing. Um, the thing that is disadvantageous about this is just that you really need to have the UI available to be able to kind of even start with this, right? And then what I've seen is that there's a bunch of vendor tools that are touting this approach, and they let you do the recording and they generate, you know, the API test, but they're missing the learning, right? They're kind of more translating those things into API tests than actually generating new tests and so on and so forth, like things like Diani's approach. But nonetheless, I think that there's promise here to do more work in investigating this, and it's good to see at least some traction in the industry around this type of approach. All right, at a unit level, as you can see, as we start going down the levels, we start increasing the gaps that we see in the industry around this stuff, right? But here, practitioners are trying to train AI to automatically write unit tests in high-level programming languages such as Java, right? And there's two popular features around this type of framework for unit testing. The first one is just automatic source analysis to generate unit tests, right, that reflect program behavior, right? And so it's not really connected to your Oracle, right? So warning flag should come up there. What I liked about Gordon's approach, for example, from the API level, is at least it took some external specification of behavior from Swagger, right? So here is definitely needing something like that. The other kind of feature that you'll see with these tools is the integration with version control systems to monitor source code changes and keep the tests up to date, right? To kind of help deal with test maintenance. And so this is a interactive widget that DiffBlue has on their website for their product DiffBlue cover, right? There's interesting online widget that you can just go and use and see kind of how it works, right? But that's, again, very interesting to see some traction in that that space, right? So there's a firm out of the UK. I actually met their CEO at a Quest for Quality conference a few years ago. So check it out if you are interested there. And how this kind of works, again, without getting too technical or too deep, much of the work in this area builds on advances in AI for generating text and natural language, right? So initiatives such as OpenAI's GPT-3, which combines natural language processing with deep learning models to generate tests that you probably couldn't tell if a human wrote it or, you know, it was written by a machine in this case, right? And so here you'll see that there's quite a bit of work. This is on the right, you'll see Copilot, GitHub released the Copilot product, which really is generating full functions, right? And these are, you know, kind of replacing the programmers, right? So if we can replace the programmers, we certainly can replace the test automation code, maybe, right? We'll see. All right, so now looking at another dimension, looking down the quality attribute route. And so, you know, we'll start with performance. And of course, there's different levels of performance. Like I mentioned, our whole thing at Test.ai is about scale, right? And so we are looking to test the world's apps, not just one app, but all the apps. And part of that is addressing the application domain. As you go through an application and you're testing it, you can obviously, at the UI level, you can track steps and gather performance metrics. And that's what we can do with our product. And not only can you now start to see how your app performs on certain key scenarios, but you can compare its performance to similar applications from your competitors, right? So for example, you can generate reports that compare the results of any retail app to all other applications in that domain, right? And the way that this works is that the tests are running, the bots are running through these goal-based tests on these key scenarios and applying that same test across the board within a given category. And then they compute a percentile rank that puts your app, you know, against all the others in that category. And that's really powerful test information to have if you're a leader in your space. Like, you know, why is our performance in this particular function so much worse than one of our competitors? That drives change, and that's valuable information. The other level of that is just not looking at the domain, but trying to test the whole store and test everything in it. And, you know, again, works in a similar way where the bots are crawling through the apps, right? And looking at key user flows and using computer vision to make decisions. There's an action pool. So now you're a little bit more exploratory and autonomous at times, where you're clicking, swiping, entering text. You're doing things like maximizing windows. You're looking for all these strange things that could happen. And the impressive thing here is really just the scale that AI allows us, you know, to test. So we talk about 1,000 apps per night, and every month doing runs of 5,000 apps at a time. Like, just like, if you want to talk about a tour de force or a feat of strength, like that level of testing, even at a rudimentary level where you're just kind of looking and comparing metrics, is impressive, right? And there's tons of benefits and returns on that investment. If you are the owner of the app store and executive, you want to know the health of the overall store because you're accountable to that. You also have vendors, people who are submitting their apps to you, and, you know, identifying issues like that helps with the vendor relations and helps you to get those things and get them to get their stuff fixed, right? So you're providing them valuable information. And then if you're a software engineer or software tester, we can do things like show you the path that, you know, most of these bugs and issues occurred on, and that's good for debugging and fixing and improving quality, which is what testing is all about, right? All right, another aspect is a lot of the work that we have done on testing data centers, right? And you know, this is really about doing some top of the rack upgrade testing, and the context here is game streaming, right? So as I said, these dimensions interconnect, right? And so how this works is that, you know, you have a very large scale where you have 165 parallel accounts and sustained load running for a 10-hour period. You let the bots loose at scale. And so we execute 15,500 tests in that space of time. Everything's fully automated and there's secure communication between the bots and the cloud environment. And that's just crazy to imagine that you can take what would normally take a human 21.52 man days, right? You know, or what is 1,291 man hours, or 75,500 man minutes, right? All of that time squished into 10 hours for bots to do it, right? And you know, this is, I think, one of the whole points of not only leveraging cloud compute to do testing, but combining that with AI to be able to do it across the board and, you know, just kind of knock things out the park. And obviously, there's no point to doing testing if you're not going to find bugs and issues. And so you'll see our system picking up, you know, game streaming bugs, right? Fail to start stream, or, you know, the stream connection issues lost. You get black screens after you load a game and that sort of stuff. And all can be detected just using computer vision, right? And one of the key features that I love, especially the way that the world has been going with, you know, really uh, testing as a feature and embedding testing and feedback into their apps, is that our bots go through and find these issues, which is, again, impressive in itself. But then they actually go back and submit, or on the fly, also can submit those bugs straight into the system to go straight into engineering. So that's again, pretty direct value feedback for the stakeholders. So there's still gaps in AI for performance, in particular on the end-to-end space, right? So, you know, application benchmarking and even doing data centers testing is not the same as doing end-to-end performance testing of your application, where system level performance testing really should emulate production traffic using hundreds and thousands of concurrent users under real world scenarios and transactions, right? And, you know, again, I think when you start to look at our community and you see like little pockets of engineering happening and innovation happening, it's pretty exciting. So Kaushal Dalvi over at the Ultimate Chronos Group has been building a tool for end-to-end performance, right? And the vision there is it's pretty ambitious, right? Is to have full self-service system that automatically produces load runner scripts, complete with parameterization, correlation, and logic. And, you know, the internal tool emulates the basically emulates what the performance engineer would have to do. So you eliminate this need for manually rescripting and all that stuff, right? And so, you know, I think the long-term goal and the long-term vision there is to really use ML to drive smart rules and smart parameterization and stuff like that, and smart correlation. So also, if you're not tracking Culture, please check him out. He gave a presentation at Start East last year, which should still be recorded somewhere. So check it out. All right, last dimension here is to look at usability. Well, actually, I think there's two, because there's usability and accessibility that we'll look at. But one of the things that we always hear is so hard or even impossible to test is usability, right? You could test all sorts of stuff. 2 + 2 is 4, but you can't check if there's a good look and feel. Well, AI is kind of making that not true anymore and giving us some power to really test what are these uh, good designs versus bad designs, right? So each mobile development platform has some sort of guidelines, like whether you're not talking about Apple, there's these human interface guidelines. And for Android, you have their design for Android guidelines. And you know, a great way to catch these issues is with AI. You train the bots to examine the screen, right? You feed them examples of good designs and bad designs, or areas where these design guidelines have been violated. And you don't have to look at code or any application specific checks. Instead, only visual elements, right? And you know, we can find these in a repeatable manner and alert folks. And this is a major hurdle, especially for the app stores who try to run these things manually, and it's a huge effort that goes on to do that. All right, on accessibility, Keith Briggs, also over at the Ultimate Kronos Group in 2019, published a paper around site-wide accessibility testing, right? A11Y, or ally, I like to call it ally testing. And this is pretty cool, because the whole point here is that you're starting to combine the power of the bots to explore, right? So your bots can explore and build models. And this is just a short video of Ally in action, where it uses bots to build an application graph with all the pages. And then it can easily plug in tools like Axe, right? Which, if you guys have ever used Axe or Lighthouse, you know, the pain of these tools is that the developer or the tester has to go and fire up their app to a specific page and then run the analysis and then keep doing that. So having an automatic way to explore and then add on these behaviors with accessibility testing tools is pretty legit, right? We saw that there's going to be some talks on accessibility tools that should be pretty cool. I think one good thing to note here is that you know, there's still a lot of room in this space for automation of accessibility. I mean, a lot of the tools don't cover a lot of the higher level automation test cases that need to be run if you're truly gonna have something meaningful for accessibility. But being able to start here is just a good step for you know, an industry that is trying very much to keep pace with what is a very important area of testing. All right, so now let's look down at the problem domain, and we're really going to take a look at two very specialized domains, which you probably know by now because we talked about them. First one being video quality testing or video streaming. And, you know, the thing is that how we do these things today is really, really, really painful, right? So, you know, how this is really done is it's 100% manual. The best practice is really to literally stream the video and ask a bunch of people to watch it and rate it, right? Using this mean opinion score scale. And it's just a real nice, fancy scientific way to collect these scores. But clearly this is slow, it's expensive, and it doesn't scale, right? And when it comes to automation, there is some, right? You have a lot of frame by frame, pixel by pixel automation being applied here, where you comb through every frame and look for different failure modes like the blank screens, poor frame rates, etc. But this is also very painful, right? It's almost like, you know, find the video bug in the haystack here, right? And so there's just a need for something better, and this is where AI can really thrive, right? And so what this is all about is first training the bots on those common failure modes, right? And so they want to use those failure modes as features in their model, along with the category of video, because not all video genres are created equally, like live action versus slow scenes versus animations and that sort of stuff. And then the third major feature is to have the bots actually watch this video and focus on the areas that humans would, right? Because a bug in a video stream may or may not be noticeable, or you may or may not care about it, depending on if you even notice it on that part of the screen, right? And so, again, just like humans would, we train classifiers, so we collect these features. We trained um, basically on a set of videos with associated mean opinion scores. So what you're really trying to do is train the bot to mimic the human judgment. And again, this is where AI really thrives. And you can see here after several iterations in a particular genre, I think this is our Asian fusion genre, you can clearly see from this curve that at this point, there's a 93% correlation between what the bots are predicting and what the actual human scores were. And at that point, 93% accuracy, no one's going to complain. It's pretty accurate. And actually, when I look at the curve, sometimes I tend to favor the predicted score curve over the sharp, painful, kind of weird things that kind of tend to go on in the other one. And so that's pretty awesome to see that kind of stuff happening. And this opens up. I mean, that kind of testing really opens up uh, the space for just doing better and different types of automation. But there's still one other little piece that needs to be taken care of, and we've also done some work with that where we've used Raspberry Pis to allow us to just plug into any kind of HDMI interface, or we use it to interface with the game controllers and that sort of stuff, and then add AI-driven automation so that we can now automate things like Roku and the Amazon Fire Sticks and those kind of things, right? Which we've never really seen that kind of stuff before. And then you'll see that we also do it on PlayStation and Xbox and that sort of stuff. And that's just really cool in terms of a superpower, right, to have. All right. So last topic here is gaming. I think I'm good on time. But AI has been playing games for as long as we can remember, right? But it was in 2017 where we had OpenAI creating this bot that went out and defeated the world's best Dota player, right? And in a small match, right, a 1v1 tournament, but really the bot learned from scratch, right, using reinforcement learning and self-play. And then 2 years later, they'd create OpenAI 5, which was really using reinforcement learning at an even larger scale to train the bots to play together as a team of 5, right? And so we're talking about having bots learn by playing over 10,000 years of games against itself and then reaching an expert level, right? Human AI cooperation. And when I think about that, right, then it makes me think that extending the bots while they're playing games with classifiers for detecting cosmetic bugs and gameplay bugs all of a sudden doesn't seem so hard, right? Like it doesn't seem to compare to the gravity of beating an expert at one of these games or beating a team of experts at these games. And so, as you can imagine, traditional approaches to game testing are pretty manual, right? And a manual effort, but again, not fun. It's not smiles, enjoy the game, be happy kind of thing. It's more repetitive, like I need a different life kind of automation, right? Or sorry, testing. And when it comes to automation, there's not much help there either, right? There are at the lower levels a lot of frameworks that help you with the game logic, but when it comes to doing end-to-end testing, either it goes back to the whole manual piece, or there's automation that's either very brittle, very prone to breakage because it's very kind of hard code, move north, move right, that kind of stuff. Or it does the pixel comparison, which we know is very brittle as well. But you know, uh, most of the bugs, right, will happen not in this vanilla environment, right? That's only a dev environment, very plain. it'll happen for that end user experience, right? And that's where they always revert back to the manual work. Um, but game testing is a huge, huge area, right? Very important, especially now the gaming market is booming due to the pandemic and stuff like that. But there's several dimensions to this, right? So there's the core functionality of the gaming application itself and making sure that that works. There's the game stores, which is a source of revenue for all these major game companies, right? So that's important. There's the visual look and feel and how it sounds, right? All of those things, which again, traditional automation doesn't necessarily tackle. And then there's gameplay, right? And again, if you think about automation frameworks from an end-to-end standpoint, your Seleniums aren't going to help you with this, right? Or your Appiums, right? So AI is almost like the only alternative that you have, right? Again, there's some other ways that you can do it, but it's a very powerful way to step into this world of game testing. And so, you know, again, anything with a screen, so it doesn't matter. It doesn't matter if it's a game. It doesn't matter if that game goes into gameplay. Like, you can compose tests that use elements and then actually write a flow that goes straight into the gameplay and then interact or verify the game elements, all using computer vision and machine learning. And it gets deeper, right? Because you want to be able to train the AIS to detect different objects, right? To classify different things, as we saw from the foundational slide. So here you can detect the character, right? In this case, Maverick, and you can train a classifier for him. You can also train a classifier for the accessories that he might put on, like in this case, the adventure pack. And then now that you can traverse through the application and select different things from the menus, you can now do a test that runs through, selects different configurations of the visual assets, and then verify that it is what you think it is at the end of the day, right? And so that is pretty powerful in terms of automation. Those are the kind of tests that people are running manually and finding glitches. But of course, it doesn't stop there. Like, you got to be able to identify, if you do find a glitch, where the glitch is, right? And so again, machine learning can help you with that. We train models to really remove the background and be able to deal with the asset itself and compare a baseline image that we trained on with the current observation to see if there's any changes. And if there's any changes, you can create a difference mask that really highlights exactly where the change was, right? So here, this is a typical, change where, obviously just for illustration purposes, it's like, okay, it's obvious what changed here. But if there was just a little pixel here, a little pixel there, it didn't matter. The diff mask would allow you to see where that is. And that's where, having a pixel by pixel comparison can be useful, but not for the base level of automation, only for showing me really when I want to find out exactly where something is wrong or what it looks like, so I can go back and show this to the animator and say, hey, we changed something and it broke something in our system. And what we do with this in a production setting is actually lay this diff mask over your original asset and fade it in and out so that you can actually overlay it on the original asset to see exactly what the difference is. So that's pretty cool. And, similar to the visual diffing problem, you can also now look at comparing audio for similarity, right? And so again, without getting into all the technical details, and you can use ML models to train this, or you don't. It's still within Python. There's a lot of different ways to look at the cross correlation between things to look at the similarity of things, right? And so it's all available there as an extension. And again, it's not just about using AI and ML to do everything, but if it's available and you can extend it and mix and match these things, I think the end result can be very, very powerful, right? So here, this is just, again, base observation that you have, right? Some base image, and you'll see what that looks like. Your test observation, and what you do with the cross correlation is that you're really seeing if this graph really fits over or sweeps through this other graph right here as well. So pretty cool. All right, and the big thing is really about gameplay, and we're seeing that there's just more and more demand for really validating things in game, because there's a lot of manual testing happening around games, right? And so this again might look like magic, but we can drill into exactly how it works. On one side, there's real-time object detection. So by now you should be familiar with the fact that you can just train things on images, right? So we train here the bots to recognize enemies or friendlies or generic objects or the active weapon, right? Or also things like the HP, right? You can do things like this bar here, for example, for the health is somewhat depleted, right? And we can calculate by looking at the images and classifying. We can write a calculator that estimates how much HP we have just visually looking at it. And of course, the object detection is just one thing because you're going to leverage that to validate that things look and feel how you assume they would. But you also need to train the bots with goal-based reinforcement learning. So you model the actions that the bots can do. In this case, go forward, back, aim, strafe left and right. There's mobile Call of Duty here, so the shoot happens automatically in the default setting. But then you give it rewards, right? So we look at the HUD and we can pull out using OCR what the kill count is and assign a reward to the bot for increasing the kill count. And we can also do things like give a negative reward for decreasing health, right? For taking on hits. And things like aiming at enemies, right? So here, visually, once you lock onto an enemy, the crosshair becomes red, right? And so we can detect when that becomes red and use that in a reward system to say, okay, I want you to do more of this. I want you to change that crosshair from white to red by targeting on enemies and learning that way. And again, pretty cool, because what you're saying is that all that research that was applied to gaming and that is being applied to gaming still to play games can now be combined with object detection and now things like visual diffing to put a comprehensive solution together for testing gameplay using AI. All right, so to round it up, there's just this rapid growth. I've shown this slide over the years in almost every talk that I give once some time goes by. And I've just seen it grow and grow and grow, right? And so the rapid growth in the use of AI for software testing just continues. And there's vendors, I focus here on industry related things, right? Internal tools. There's still a lot of academic research and a big body of academic research out there as well that needs to be transitioned into industry. But it's exciting, right? And for me, I am just like at awe in the fact that we're seeing basically AI-driven testing turn into this kind of full stack solution where we have AI for the core testing concerns at the different levels. And now we're seeing AI being used to address cross-cutting concerns like usability, performance, and security, and that sort of stuff. And I'm just really happy to be a part of it and work for a company that's a part of doing these things. I think without folks kind of working together on these problems, we're not going to make much traction at all. And it'll take some, trial and error and failures and all that stuff. And it's the exciting thing about being at a startup company, I think, for me. But then I'm also thinking as a quality practitioner, doing this stuff is becoming, in my mind, a necessary step because we are building AI, like we're building it, like they're building it, even if we're not testing it, they're building it, right? And I think that the key thing that I've learned over the years from all of my research is that when you build something that can learn or adapt at runtime, right? It's no longer just test it beforehand and release it. Like while it's out there, it's going to be learning and it's going to be changing, right? And you need a different strategy for testing. And that's a big passion of mine, to look at testing AI systems, and even that the future might involve embedding some of this AI-driven test automation technology into the runtime of the system itself to be able to have it, test itself as it learns online. But for now, we need to be thinking about how to test these systems both offline and online until all this automation and full stack automation catches up. And so with that, I wrap it up and, open any questions. You can always connect with me on social media. Kevin knows how to find me all the time. I try to hide from him, but he works it out. And so we can open up. Kevin?
Yeah. Okay, cool. Thank you, Tariq. Awesome job.